Now this video is going to walk you through how to hook up a clamping diode. Now a clamping diode is best used for a circuit that turns something on and off that can create a pretty large voltage spike, like an air conditioning compressor coil or something of that nature. So we don't have anything really in the box here that creates a huge voltage spike. So what I'm going to use, I'm just going to use the electric motor right here. So with my electric motor, I'm going to switch it. I'm going to put a switch on here so I can turn it on and off. And I'm going to put it on the ground side of the circuit. I like to switch my circuits on the ground. It doesn't really matter. You can switch it on the positive side if you want to. But I like to switch it on the ground. Now, if I hook this up, I've got my power coming out of here, goes into my motor, goes through my motor, goes to my switch, and then to ground. So if I turn my switch on, my motor turns on and works. Now, if this was a big AC compressor coil, I would want to see if I could eliminate any voltage spike that may occur when that thing turns on and off. And I do that with a diode. So what I'm going to do is I'm going to put the clamping diode right up here. And the clamping diode has to be in reverse bias. So in other words, when the electricity comes from the positive over here to the motor, the diode's going to be hooked up in parallel, but you don't want the electricity to pass through the diode. Because if you put it in forward bias, now remember the biasing of the diode, that just means what direction the current is going to flow through the diode. So if I put it in here, the current flows in the direction of the arrow on the diode. So if I put it in here, the diode has almost no resistance. So if I hook this up in parallel, what I've done is I've given the path for electrons with almost no resistance to go to ground. And so what will happen is you'll eventually burn up your diode, but your diode will get pretty hot and your motor won't turn on. So to hook this up correctly, we need to put it in reverse bias, which means that the electricity going through the diode can only go in the reverse path, not the forward path. So we're going to hook this up in parallel. And I'll know that I got it hooked up right because when I turn it on, the motor works like it's supposed to. And what happens is if this was a AC compressor coil or something that generates a lot of voltage spike, when you turn it on and off, turn it on and off, that excessive voltage spike is allowed to come through the diode and then back to the motor, and it just kind of circles around back and forth like this until it dissipates, rather than going all the way back up the circuit. Now, let's just say I hook this up backwards, like I wasn't supposed to hook it up. And I'll show you what happens with this, just so that you can learn from my mistake and not do it yourself. So if I hook this up like this, I'm going to turn it on. See, nothing happens and my light goes out over here because I've just created a short to ground is what I've done. So you notice I didn't leave that on very long, because if you leave that on very long, this transistor will get really hot and then it'll burn out and this is damaged. So you don't want to do that. So if you turn the switch on, your motor should turn on and spin. If it doesn't, take a look at the way you've got your diode hooked up and make sure you don't have it in forward bias. So to hook up a clamping diode in a circuit, it needs to be hooked up in reverse bias. And that wraps it up for this video.